20 milligrams of omzaporols, and the dose required is 20 milligrams. As such, 1 tablet is required. 5 milligrams per 1 milliliter of capitopril, and the dose required is 25 milligrams. As such, on the calculator, I will do 25 milligrams, which is the dose required, divided by the dose that's in it, divided by 5 times 1. So we'll be getting 5 milliliters. On to the next question. So there is 125 milligrams of fluvoxacillin per 5 mils, and the dose required is 500. As such, 500 divided by 125 times 5 equals 20. So 20 milliliters will be required. On to the next question. 250 milligrams of amoxicillin per 5 mils, and the dose required is 1000. So 1000 divided by 250 times 5. So it will be 20 milliliters that we'll be getting. Chlorazepam, 10 milligrams per 1 milliliter, and the dose required is 25 milligrams. So 25 divided by 10 is 2.5. Okay, on to the next question. Oxycodone, 1 milligram per 1 milliliter, 10 milligrams required. So 1 divided by 1, so it's 10. On to the next. Benzotropine, 2 milligrams is the dose required, and it's 1 milligram per 1 milliliter. So 2 divided by 1 is 1. So it's 2. We are giving 40 milligrams of enoxaparin, and it's 40 over 0.4 milliliters, and the dose required is 40. So it's 40 divided by 40 times 0.4, which is 0.4. On to the next. So it's 80 milligrams of gentamicin per 2 milliliters, and the dose required is 80 milligrams. So 60 milligrams. So 60 divided by 80 equals 0.75 times 2 is 1.5. Haldalparol, the dose required is 7.5 milligrams, and it is 5 milligrams per 1 milliliter. So 7.5 divided by 5. Oh, 7.5 divided by 5. It's 1.5. It's 12.5 milligrams per 1 milliliter of prochlazepam, and the dose required is 12.5. So 12.5 divided by 12.5 divided by 12.5. So we have 500 milliliters of sodium chloride over, 500 milliliters of dextrose with sodium chloride over 6 hours. So we would do 500 divided by 6. On the rate would then be 83.333, so we just round it up to the closest number, so 83, and the volume would be 500. Right, on to the next one. Sodium chloride, 500 milliliters over 4 hours, so we would do 500 divided by 4 equals 125, so turning on 1, 2, 5, and the volume is 500. On to the next, we have packed red cells, 200 milliliters over 3 hours. So 200 divided by 3, which means that the rate would be 66.6, but since we're rounding to the closest number, it'd be 67, and the volume would be 200. Check, yes. Cool. On to the next question. So we have dextrose with sodium chloride, 1000 milliliters over 12 hours. So 1000 divided by 12 equals 83.333, recurring. So we're rounding it to the closest number, so the rate would be 83 and the volume would be 1000. We have platelets, 100 milliliters over 1 hour. So if we have 100 divided by 1, it's 100 and 100. Yeah. On the rate would be 100 and the volume would be 100. Continue to the next. So on question 21. 10% of dextrosterone, 500 milliliters over 8 hours. And we are finding out the drop rate. So to do so, we would do, so you have to find out the hours in minutes. So 8 times 60 kills 480. We have 500 milliliters, so it's 500 divided by 480 equals 12.5, and we times it by the drop factor. Sorry. What just happened? 500 divided by 480. Yeah, times drop factor of 60. Okay, so we've got 62.4, but to find the number, we're going to do it by 15 seconds. So I'm going to divide that number by 4, and it equals 15.6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm just going to double check with this one. So we're looking for the drop rate of 15 drops per 15 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's correct. On to the next question. So we have dextrose with sodium chloride, 500 milliliters over 8 hours. So again, we check for hours. 8 times 60 equals 480. We have 500 milliliters. So it's 500 divided by 480. And the drop factor for this one per milliliter is 20, so we times it by 20 to get, sorry, some mistakes being made. My zero is not working. Times 20, yeah. So it's 20.8 recurring, 20.83 recurring, and to find it per 15 seconds, we're going to divide it by 4, because 4 times 15, 16, which is a minute. So we're looking for a 5.2 drop rate in 15 seconds. 1, 2, 3, 4, 5. Yes. So I'm going to click on the sign. That's correct. On to the next question. So we've got dextrose with sodium chloride, 500 milliliters over 12 hours. So 12 times 60 equals 720. So it's 500 divided by 720 equals 0.69. And the drop factor is 60, so times 60 equals 41.6 recurring. To find it in the 15 seconds, we divide by 4, and we have a drop rate of 10 drops per 15 seconds. So I'm going to move it. 1, 2, 3, 4. It's already too fast moving down. I'll stop. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's already too fast. Move it down one more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pretty keen on this one. Check answer. On to the next. Sodium chloride, 500 milliliters over 12 hours. So again, we know that with 12 is 720. So we're going to clear that. So it's 500 divided by 720 equals 0.69. And the drop rate is 90, so times 60 is the drop, right? So again, it's the same, divided by 4, and we have 10.416 recurring. Too quick, I think. Let's try this on. 2, 3, 4, 5, 6, 7, 8, 9, 10. Check answer correct. On to the next question. Dextrose mixed with sodium chloride, 500 milliliters over 6 hours. 6 times 60, turning it off. 6 times 60 equals 360. 500 divided by 360 equals 1.38 recurring, and we're times by the drop factor of 20, which is 27.7 recurring. We then want to divide by 4 to a 6.9, so we'll round that to 7. One, 2, 3, 4, 5, 6, 7. On to the next question, correct. Normal saline, 250 milliliters with 25,000 units of heparin. The question asks how many units. The rate currently shows 13 milliliters per hour, and the question is how many units of heparin are being administered to the patient every 1 hour. So every 1 hour. So we do 25,000 divided by 25 equals 100. 100 times 13 equals 13,000. So I've put 1,300 units per hour. Correct. On to the next question. Normal saline 250 milliliters, and there's 25,000 units of heparin. The volume rate, the rate is currently at 12. The result of the APTT are back, and the doctor has ordered an adjustment in the current infusion rate to 900 units an hour. On the volumetric pump above, make the necessary adjustment to set the correct infusion rate to milliliters an hour to deliver this. So it's currently set at 12. If we divide 25,000 divided by 250 equals 100, and it was set at 12, that means that the rate should be 1,200. If the rate currently is 900 units per hour, sorry, the infusion rate, it should be 9. Next. We have normal saline 50 milliliters and units 50 milliliters, so it's 1. And how many units of insulin are being administered to the patient every 1 hour? So if we do 50 divided by 50, it equals 1. If we times 1 by 3, the answer should be 3. Correct. On to the next question. Normal saline 250 milliliters to 25,000 units of heparin. How many units of heparin are being administered to the patient every hour? We have a rate of 10. So if we go back, we have 25, like always, whoopsies, divided by 250 equals 100. 100 times 10, 1,000. Yeah. So per hour, it should be 1,000 units. On to question 30. So there's 250, the fluid order is 250 milliliters of normal saline, and there's 250,000 units of heparin. So once again, it's 100. Rate is 12 milliliters an hour. How many units of heparin are being administered to the patient every hour? So if we do 100 times 12, the answer should be 1,200. So 1,200 units per hour should be administered. Complete.